So today we're going to take a little look at how the electrons in an atom are configured. So if I start off looking at oxygen, if I look on the periodic table, I can see its atomic number 8, so it's got 8 protons and it's also got 8 electrons. If we start putting them into shells, we can see that we'd have 2 on the first shell and there'd be 6 electrons left on the second shell. So our electrons go 2, 6. Let's look at something a bit more complicated. So if we look at aluminium is atomic number 13, so it's got 13 electrons. And if we start putting them in, so we'd write aluminium in the centre, and then we'd put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons, and then 1, 2, 3. So we'd end up with 2, 8, 3. Now, I'm going to look at this in a slightly different way. So if we were to draw these like in a graph, we could show how these energy levels, these electrons are in energy levels, and that our first energy level, our first shell, we would consider as being closest to the nucleus. So if we draw on a little line to show that it's the lowest energy and it's the closest to the nucleus, and we're going to say we've got our first shell, and we can see it's got 2 electrons in it, so I'm going to draw on 2 electrons. And we've got our second shell is further from the nucleus and it's higher in energy, so I'm going to draw a longer line here, and this one's got 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And then I've got a third shell that's got 3 electrons, and this shell is further away from the nucleus and it's higher in energy. And it's got 1, 2, 3. So I'll use the little single-headed arrows to show individual electrons, and we'll talk a little bit more about that on the next bit. So I'm going to look at this graph in a little bit more detail. So if we look at this chart in a little bit more detail, we've got our different energy levels. So this is our first shell, so we call it 1, and it's the one that's closest to the nucleus and it's got the lowest energy. And then we'd have our second shell, and we'd have our third shell, and we'd have our fourth shell. And this is what you've learned at GCSE, is that you've got shells that are lower in energy, are closer to the nucleus, and as you get further from the nucleus, we gain in energy. Now what we're going to do is we're going to take that model that you've learned at GCSE and make it a little bit more complicated. And I'm going to tell you that shells are actually split into subshells, and that those subshells are made up of things called orbitals. Now, orbitals you can kind of think of as being like a space where electrons can occupy, okay? And you can only ever have 2 electrons in one orbital, and those electrons have got to go in opposite directions, because they're both negatively charged. They're not going to want to be in the same space, so they get around that by spinning in opposite directions. So I'm going to replace these lines with boxes. So, okay. So we're going to get rid of that line. And I'm going to draw a little box. Okay, and this is going to be our first orbital, and this orbital is called, this is the 1s. Okay, now this is really easy to remember. The first energy level has 1 subshell, the 1s, and it contains 1 orbital, and that orbital can hold a maximum of 2 electrons. So I'm going to draw 2 electrons in there to show you what they'd look like, just like we did on the other one. So 1 electron or 2 electrons. Our second energy level, you guys know, holds 8 electrons. Now our second energy level gets split into 2 subshells. So the number of the energy level tells you how many subshells it splits into. Second energy level splits into 2 subshells. So if I just erase that line, I'm going to draw some boxes again. And we're going to call this the 2s, because it's the 2s orbital, and this one here is known as the 2p. Okay, so we've got the 1s, the 2s, and the 2p. So the 1s can hold 2. The 2s is the second energy level. It can hold a maximum of 8 electrons. 2 can go into the 2s. So we're going to put 2 electrons in there. And then we can have up to a maximum of 8 electrons in the 2p. Now, electrons fill up orbitals a bit like people getting on the bus. They sit on their own until they have to join up. So the 2p would go 1 electron there, then there, then there, and then it would fill up with the next ones here. Okay, so we've got the 1s, the 2s, and the 2p. And then the 3s would continue in the same way. So our third energy level is split into 3 subshells. We have the 3s, the 3p, and the 3d. Okay, the 3s has 1 orbital, which can contain 2 electrons. 1, 2. The 3p has 3 orbitals, just like the 2p, and can contain 2 electrons in each orbital. So 1, 2, 3, 4, 5, 6. And the 3d has 5 orbitals. Again, each one can contain a maximum of 2 electrons, and we fill them up one at a time and then pair them. So we can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons in the 3d. Now, if I add in the fourth energy level, the fourth shell is split into 4 subshells. Okay. And we have, again, we're further from the nucleus and we're higher in energy. Although you might notice that there's a slight overlap between the 3D and the 4S, and this is important later on. So you need to remember that the 4S is ever so slightly lower in energy than the 3D. Okay, so this is the 4S. And then we have the 4P with 3 orbitals, and the 4D with 5 orbitals, and the 4F has 7 orbitals. And if we were to fill all of these, and I'm not going to, but we would have 2 electrons in the 4s, and we can fill 1, 2, 3, 4, 5, 6 in the 4p, and we can fill 10 in the 4d, and we can put 14 into the 4f. Okay, let's have a look at what we do with individual elements then. So if we consider, say, oxygen, and oxygen has 8 electrons, so we would start, and the rules are that we start from the beginning. We always fill up from the lowest energy level first, and we don't pair up until we have to. So oxygen's got 8 electrons, so it's going to have 1, 2 in the 1s, 1, 2 in the 2s, that's 4, and then we'd have 1, 2, so 3, 4 in the 2p. So it's what we would write down for oxygen is we would write that it is 1s2, 2s2, 2p4. So you write a big number to show the energy level. You then write the name of the orbital, so S, P, D or F. And then as a superscript, you put the number of electrons that are in that orbital. So oxygen, 8 electrons is 1s2, 2s2, 2p4. Okay. And we can check that we've got 8 electrons by adding up the numbers in the superscript. Let's look at another example. So if we look at potassium, potassium has 19 electrons. If you're doing this at GCSE, you would know that would be 2 in the first shell, 8 in the second shell, 8 in the third shell, and 1 in the fourth shell. So let's have a look how that looks on our subshells and orbitals diagram. So potassium, so we're going to put 2 in the first shell, so that's 2 in the 1s, 1, 2. And then it's going to have 8 in the second shell, so that's going to be 2 in the 2s and 6 in the 2p. 1, 2, 3, 5, 6. And then it's going to have 8 in the third shell. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. So we're now up to 18 electrons. Now the 19th electron, you might think would go into the 3D, but if we remember, the 4s is lower in energy than the 3D is, so we're going to put our final 19th electron into the 4s. So our overall electron configuration, if we were to write it out, is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Okay, we can add up, check we've got 19 electrons, we've got 2 plus 2 plus 6, that's 10, plus 2 plus 6 plus 1, that's another 9. We have 19 electrons in total, and that would be known as the electron configuration of potassium, showing how its electrons are arranged into energy levels, subshells, and how, if we draw the whole diagram, how they're arranged into orbitals. So let's just have a final note on how we can use the periodic table and how this all goes through the periodic table. So the periodic table is divided up into blocks. So the first part of the periodic table, this block here with the alkali metals and the alkali earth metals, this is known as the S block. And that's because the highest electron in these elements, so the last electron, if it was going to lose its highest energy level electron, is in an s orbital. These ones over here, where the non-metals mostly are, although there's some metals in there as well, this one is known as the p block, okay, and that's because their highest energy electron is in a p orbital. The big block in the middle with the transition metals is known as the D block, and you've guessed it, this one at the bottom is known as the F block. And what you can do is you can almost see the electron configuration and the periodic table as working together, almost like coordinates on a map. So if we consider the example we just looked at, potassium, it finished with 4s1. So that 4s1, so potassium was 4s1 as its outermost electron. That tells me that the highest energy level electron is in the 4th energy level, so the 4th period, and it's in the S block, and it's only got 1. So if we look, potassium is here, it's 4th row down, 4th period, it's in the S block, and it's got 1 electron, so it's only got 1 out of the 2 possibles. Okay, thank you for listening.